These are notes for Honors Math 3, Unit 3, Objective 8. Although I'm actually just doing a couple of problems from the worksheet itself, and I'll be explaining what's going on. If we look at the title of the notes, it says find all the roots for the polynomial function. We've been doing that for a while. It's just the problems are getting a little bit more complex. And the other part of the title, write the equation for the polynomial function given certain info. We've been doing that also for quite a while, and it's just more the fact that we're getting to sometimes a little bit more complex situation. Okay, so problem number 2, find all the roots for this polynomial function, 4x to the third plus 23x squared plus 34x minus 10, if negative 3 plus I is a root. Okay, now, since this is a third degree polynomial function, 4x to the third, we know that there are a total of 3 roots. And I've also been talking to you about the fact that when we have imaginaries, imaginary roots come in pairs. And yesterday, the previous lesson, I even talked about the fact that imaginaries come in conjugate pairs. So since imaginaries come in conjugate pairs, the fact that I gave you one imaginary root, effectively, I've given you 2 of the 3 roots for the problem. And so remember that conjugate pairs, they're in the form of a plus b and a minus b. So if negative 3 plus I is a root, then negative 3 minus I is also a root. And so this is a conjugate pair. So conjugate, sorry, let me spell it correctly. Conjugate pair. So it's in the form of a plus b and a minus b. Okay, now we have a couple different ways we can deal with this, and when we were given roots before, what did we do? We divided and reduced the polynomial so that we can finish finding all the different roots, and that's what we're going to do. Now, we have 2 different ways of dividing. So one way is with long division and another way is with synthetic division. And I'm actually going to show both ways, and you can determine which way you like to do this better. So I'm going to show the long division first. Now, to do long division, we can't have the roots in this form. We can't have negative 3 plus I and negative 3 minus I. Now, technically, we can, anytime we have a root, we can say x minus the root. So there's one factor of the polynomial p of x, and the other factor would be x minus negative 3 minus I. However, you can't leave it like this. Even once we distribute the negative, you can't leave it like that. You would have to multiply this out, and we are multiplying a trinomial times a trinomial. And that's, yes, it can be done, but it's not easy, and there's lots of opportunities to make mistakes. So I don't recommend this method. Now, there is another method involving the sum and the product of the roots, and that method works very nicely. However, in my experience teaching, I found that some students would get that, but a lot of students would get mixed up as to how to use the sum and the product of the roots to make the quadratic that contains those 2 functions. So anyway, quite a few years ago, one of my students discovered that if you essentially kind of go backwards from solving by completing the square, that way will work every time. And I double checked and proved it, and it does work every single time. And so anyway, Cheryl, thank you to Cheryl. She thought of that. It's something that very few teachers that I've ever talked to have ever thought about that and understood that that way could work. So what we do is do x equals the conjugate pair, so -3 plus and minus I. And so we're going backwards of solving by completing the square. So let's get the plus or minus thing by itself. So I'm going to add 3. And now that we have that by itself, now we're going to square both sides, because we're going backwards from solving by completing the square. So now, we do need to multiply out the x plus 3 quantity squared, and if you need some scratch paper, make sure you do it correctly. But that's x squared plus 6x plus 9. Now, over here on the other side, if I square the plus or minus, it's plus. And if I square I get I squared. Now, I squared, that is the imaginary unit being squared. So positive I squared is really -1. So now we're almost done. All we need to do is get 0 on one side, and I'm going to add 1 to both sides of the equation, and I get x squared plus 6x plus 10 equals 0. So this is the quadratic that contains those two conjugate pairs, or the conjugate pair of roots. So contains -3 plus and minus I. And so since it contains those two roots, therefore x squared plus 6x plus 10 will go into this function evenly. And so that's what we're going to do. So x squared plus 6x plus 10 goes into 4x to the third plus 23x squared plus 34x minus 10. Okay, what times x squared gives me 4x to the third? Well, 4x times x squared, 4x cubed, plus 24x squared, plus 40x. And what is it we do right now? We are going to subtract. And it's nice to have an alternate color that's very visible so we can see that we have distributed the negative. And we get -x squared minus 6x, bring down the next term. Okay, and then we move on to the next one. And what times x squared gives me -x squared? Well, -1. So -x squared minus 6x minus 10, and if we distribute our negative, we can see that we get 0 remainder, which is good, because that's what we're supposed to be getting if we're dividing by roots, okay? And so now, what it was actually asking for was all the roots, but we could write it in factored form right now. And so the factored form for f of x is 4x minus 1 times this quadratic that we came up with, so x squared plus 6x plus 10. So this would be in the form completely factored over the integers. Okay, the roots, what are all the roots, or the zeros? Well, obviously we have the plus and minus 3i, but 4x minus 1, what's the root coming out of that? If you set that equal to 0, we get 1/4. And then obviously the -3 plus and minus I. Okay, and so that's what we're doing with that one. Now that's the homework problem. Now for the We could also graph the problem if we needed to. We know it's a low to high because of positive 4x to the third. We can see that we have only one x-intercept at positive 1/4. And it's not a line. You know, give it a little bit of a wiggle going on there, because it is 4x to the third, and labeling the intercepts, that one is 1/4, and the y-intercept, if I plug in 0 for all the x's, is 0, -10. And so we could ask for a graph too. But really, for the homework, all they were asking for was just what are all the roots for that. Okay, now, another way to do it besides long division is to do it synthetically. Okay, and so I'm going to show you how to do it synthetically right now too. And now, when we do it by synthetic division, the first time through is going to be kind of messy, and it doesn't really matter which one of the conjugate pair that you choose. The first time through is just kind of messy. So if we did, it doesn't matter really. If we did the -3 minus I, we did that one first. -3 minus I goes in the box. And then don't forget that our coefficients are 4, 23, 34, and -10. Now we want to space this out more than normal. 4, 23, 34, and -10. So instead of just skipping one line, I would say probably skip 2 lines or at least a line and a half, because we're spreading it out more than normal this first time through. Okay, so now we're ready to get going on this, and so 4, and then the number in the box times the number down here, so -3 times 4 is -12, and -I times 4 is -4I. And then we combine like terms, and we get 11 minus 4I. And I know you're going, well, that wasn't bad. So yeah, and it wasn't. So, but next we have to do -3 minus I, the number in the box up here, times the number below the line. So now I recommend it's like a binomial times a binomial. So I would recommend distributing the -3 first. So -3 times 11 is -33. And I'm going to put both of these in the top line right here. So -3 times -4I is positive 12I. So I've distributed the -3 to the number below the line. Now I'm going to distribute the -I. So -I times 11 is -11I. And then -I times -4I. Okay, scratch paper off to the side here. So that would be positive 4I squared. Of course, I squared is -1, so this is really -4. Okay, so -4. Okay, so now we've got 34 minus 33 is 1, minus 4 more, that's -3, and then 12I minus 11I is plus I. Okay, now I'm multiplying the number in the box times the number below the line. And so we got -3 times -3 is 9. -3 times I is -3I. Now I'm going to distribute the -I from the box. So -I times -3 is positive 3I. And -I times I is -I squared. -I squared. Of course, I squared is -1. So opposite of I squared. So opposite of -1. That would be positive 1. And if I combine like terms, we can see that we are getting 0, which is very nice because we wanted to get 0 since we were dividing by our root. Okay, now the first time through is kind of messy. Second time through is really not bad at all. So we divided by -3 minus I to begin with, so now we're going to do its partner, -3 plus I, and the second time through is not bad. So bring down the 4, -3 times 4 is -12, positive I times 4 is plus 4I. Now, notice what happens to the i's here. So the i's eliminate each other, and I'm left with -1. Okay, -3 times -1 is +3, and I times -1 is -I. And so notice what happens there. And we do get 0, and that's good because we were dividing by a root, and so that's good as well. Now that we've done that, what are we left with here? We're left with 4x minus 1. And that's what we got up here as well when we did division. And so, which way is better? They're both better. Both of these methods are fine. We're going to get that remaining factor, which would lead us to the roots, and we can finish it off. Okay, so there's that problem. Now, so 1 through 4, we're dealing with problems like that. 5 through 13, we're writing the equation given information. Okay, so, and I just did problem number 8 with everybody, which problem number 8 really, it's a 4th degree polynomial. It has roots 2 plus and minus 1 and -3. And also has a y-intercept of 42. Okay, so, well, needs to be an equation, so y equals, and they always have a multiplier, as I was showing you guys earlier in the unit, and the 2 root becomes x minus 2, and the plus and minus 1, you got x minus 1 and x plus 1, and then x plus 3. Okay, and y-intercept is 42, so, that's 0, 42. So plug in 0 for the x's and 42 for the y. So 0 minus 2, 0 minus 1, 0 plus 1, 0 plus 3, and solve for a. So this would be a is 42 over 6, which is 7. And that will be our final answer. Y equals 7 times x minus 2 times x minus 1 times x plus 1 and x plus 3. Now, by the way, I noticed that there was a conjugate pair right here. Now, it's not a conjugate pair of imaginaries, but when we see the plus or minus kind of thing going on, that's typically a conjugate pair of some sort. So would this method that I taught you, would that work with any conjugate pair? Yes, it does. I mean, if I do x equals plus or minus 1, and if I square both sides, we get x squared equals positive 1, and then get 0 on one side, so x squared minus 1 equals 0. So x squared minus 1 contains the roots plus and minus 1. And so can you see the x squared minus 1 could replace the x minus 1 times x plus 1? Yeah, it could. Which one's better? I mean, they're both fine. If they want it completely factored, this one where it's x minus 1 times x plus 1, that form is completely factored. Okay, last problem. Number 13. It's a cubic polynomial. We're writing the equation. It has roots 2 and 1 plus and minus root 2. And then it also has f of 4 is 7. Okay, well, it's an equation, and they told us the name. The name is f of x, because they told us f of 4. So f of x equals a times, okay, well, 1 root is 2, so x minus 2. And then we've got the 1 plus and minus root. Well, okay, there's conjugate pair. So guess what we're going to do right now? We're going to use Cheryl's method. So x equals 1 plus and minus root 2. So x minus 1 equals plus and minus root 2. So square both sides. And we get x squared minus 2x plus 1 equals positive 2. Get 0 on that side, so bring the 2 over. X squared minus 2x minus 1 equals 0. So this quadratic contains the roots 1 plus and minus root 2. So x squared minus 2x minus 1. Okay, we do need to solve for a. Don't forget this f of 4 equals 7. That's 4 comma 7. So 7 equals a times 4 minus 2. 4 squared, which is 16, minus 2 times 4, minus 1. So 7 equals a times 2 times 7. So a would be 1/2. And so our function is f of x equals 1/2 times x minus 2 times x squared minus 2x minus 1.